Hello everyone, I'm Chunrong Huang from National Zhongxin University. I would like to appreciate the committee and also the Future Tech Awards to give me the chance to present our work. The title of our work is Few-Shot Self-Supervised Learning for AI-Based Automatic Optical Inspection in Industry 4.0. With the increasing number of products, it is very hard to apply human beings to inspect all of the products. As a result, automatic optical inspection is proposed to identify the defects of the products by using the AI technology. So let's take the print circuit board as an example. We have a camera to capture the target PCB, and then the captured images is sent to the AOI software for inspection. So here are the examples of the PCB images. As you can see, there are different digital components appears on the image. And then by using the AOI software, we can identify if there are defects appearing on the digital chips. If so, then we can remove the product from the product line. So since AOI techniques help the industry to inspect the products, there are many different kinds of AOI approaches, especially the deep learning-based approaches. These deep learning-based approaches has been shown very good performance for the AOI. However, there are several problems appear in deep learning-based approaches. The first problem is that it usually requires a large number of labeled data. So it is very hard for the human beings to label sufficient data and collect sufficient data for each product. So as you can see, the data processing takes around 80% developing time in AI projects. So it will spend a lot of time to process the training data. Moreover, if a company has hundreds of products, they also need to label all of the products for the deep learning-based training. So it is a very time-consuming process. And then the second problem is the heavy computational resources are required for the deep learning-based methods. As far as we know, it is necessary to apply GPU devices for the deep learning-based training. So in each company, they require to buy the expensive GPU devices for the deep learning training. So the cost will increase. The third problem is the training time. Because the deep learning requires to learn from a large number of training data. So the training time is very long. If you have more products, you need to spend more training time for training your AOI models. So to solve the aforementioned problem, we aim to learn the AOI models from only a few labeled PCB images and the pixels from the target components. As you know that each component will contain many pixels, so the proposed method will discover the spatial relationship among the pixels to generate a large number of feature representations. If we can generate sufficient feature representations from the pixels, then it is not necessary to learn a lot of training images. And then during testing, we compare the input PCB images with respect to the learned AI features of the learned AI models, and then identify the target component in these images. To show more details about the novelty of the proposed method, here we consider the positional combination of the pixels to generate a more robust pixel features to identify the target component. And then to solve the color jittering problem, we use the correlation of the color encoding. So we consider the color of different color channels to generate better features. And then finally, we consider the orientations of the components to generate more robust spatial features. By combining these unique pixel-based representations, we can generate very good representation for the component. And then to demonstrate the proposed method, we have developed a novel labeling user interface and the training and testing software for evaluation. So user can label the target component easily from the labeling tool, and our training and testing tool will help them to generate the AI model and the testing. So here is our experiment. We compare the proposed method with the state-of-the-art deep learning-based method. So in the experiments, we use only 3 training images for training. So it is a very picky condition and a challenge for the AI methods. So the result is shown in this page. As shown in the first column of the slide, the red rectangle shows the position of the target component. And then as shown in the second column, you can see that the proposed method can successfully detect all of the components in the PCB image. In contrast, the deep learning-based methods fails to detect the target component due to the lack of sufficient training data. Okay, here is another demonstration. The proposed method can detect the target component of different sizes. In contrast, the deep learning-based method fails again. Okay, you can also see similar results in this example. And then finally, in this example. So as you can see, with only 3 training images, the traditional deep learning-based methods fails to detect the target component. So it also shows the limitation of current state-of-the-art deep learning-based methods. Okay, so to give more detailed metrics, we show the performance comparison. And then the resolution of the test PCB images is 2000 by 2000. So you can see that the resolution is very high. However, the training time of the proposed method is less than a second, and the prediction time is also less than a second for each image. So you can see the computational efficiency of the proposed method. In addition, the proposed method is implemented by using only CPU devices. The proposed method doesn't need any GPU devices. So the proposed method can significantly reduce the cost of the factory. Moreover, as shown in the third chart, you can see that the accuracy of the proposed method is more than 95%. In contrast, the deep learning method fails to detect the target components. So the result shows the importance of the proposed method, and the proposed method can really detect the target component from only a few training images with much less computational cost. Finally, I would like to give a brief in conclusions. So our method can accurately detect the target component with only a few labeled training images. And then it can be operated in real time and by only use the CPU devices. Because the proposed method is based on the pixels, so it can be applied to any AOI images for evaluation and testing. And finally, the proposed method defeats state-of-the-art deep learning approaches and shows promising AOI usage. So we believe that our method can help the AOI industry in Taiwan and also reduce the burden of the company. Okay, thank you for your listening. And finally, I would like to appreciate the committee again to give me the chance for the presentation. Thank you.